Hello, everybody. So we are starting the Twitch, the live. So I'm Ben, the Chief Product Officer and co-founder of Ternoa. So thank you all for joining us today on the live. It's a new format with the tech team, and we hope you will like it. Today we will introduce our brand new Ternoa token bridge. Oh, you heard about it. So it's the day. The live is to present you in details how we have created a secure and low fees bridge on Substrate. And the team make great work on relooking this bridge with a new UI, a new code, better security, and more. So props to you guys. And let's watch a quick video to introduce this AMA.
Hey guys, my name is Aman. Thank you, Ben, for the quick introduction. I'm so excited to be here and finally meet the community. And I believe you guys feel the same because mostly you met the co-founders, you met the founders, you met the marketing people, but you've never met the tech guys. At least that's what I'm thinking. As I've already introduced myself, I'm a product manager here at Ternoa. I'm responsible to make your life easier. That means making my team's life a bit difficult. To also mention that today from the dev team, we have Marco and Prabhu joining us, who will introduce themselves in a bit. I'm going to moderate the session. So structure-wise, first, I would say Prabhu is going to talk about Bridge briefly, and then Marco will take over, who will discuss with you the architecture of the bridge. And then I will walk you through the bridge, the demonstration of the bridge. And then we'll conclude the session by answering all your questions. I hope that's clear. So before I pass it on to the tech guys, I would just like to remind the community that we know that CAPS is only available on Ethereum and Binance Chain, and there's not much possibility to interact with the products and features lined up for the mainnet. So in order for community to start engaging with the Ternoa ecosystem, with all the products that we have lined up for you throughout the mainnet launch, it would be necessary to bring the ERC20 and the BP20 caps token and transfer it to the native Ternoa chain. And for this reason, we have built the bridge. And I'm pretty sure you guys are eager to check it out. But before we do this, let's understand the bridge a bit more in detail. Prabhu, over to you.
Thanks, Aman. Good morning, good evening. Very happy to be here. My name is Prabhu Ishwarla, and I'm the blockchain architect for the Ternoa L1 chain. And I also coordinate the releases for the chain and also the associated infrastructure. As Aman mentioned, so we're very happy to release the token bridge, and the need for the token bridge is essentially that the CAPS tokens that are currently available are on the Ethereum network, and since we have launched the mainnet last month and minted the Genesis block, we need to find a way to bring those tokens from Ethereum to the Ternoa chain. Why would you want to bring it to Ternoa? For three reasons. Firstly, for all the transactions that you do on the Ternoa chain, assuming once the dApps are launched, if you want to mint NFTs, if you want to, add secrets and stuff like that, you'll have to pay transaction fees. And on the Ternoa chain, you need caps to do that. Secondly, from a governance perspective, it's a decentralized network. So if you want to participate in the evolution, the features of the chain, participate in voting, raise proposals, you need caps for that. And thirdly, you can all your caps that are available on Ethereum, once you bring it over to the Ternoa chain, you can participate in network security. You can stake your caps against validators, and you can earn caps rewards. So these are the reasons why you may want to think about bringing the caps token over from Ethereum to the Ternoa chain. Now, note that what we have launched right now is the AlphaNet token bridge. What that means is that we're not connected to the actual Ethereum mainnet. We've launched the bridge on the Ethereum side on the Rinkeby test network, and the bridge connects on the other side to the AlphaNet of Ternoa chain. Once we and we call this AlphaNet the public, it's the public test network. So you have a chance to try out the transfers, and if there is any feedback or improvements, we will fix them before we launch it on the mainnet. That's the background behind the token bridge you're going to see more of today. I'm going to now hand you this over to Marco. He and his team have actually developed the bridge, so who better to talk about it? Over to you, Marco.
Yeah, thank you very much for the amazing introduction, Prabhu. My name is Marco. I am the blockchain lead here in Ternoa. My job is basically to implement new features, maintain existing one, and to manage the blockchain team. Today, I'm going to present you in layman's terms how our bridge works. Yeah, let's get straight to it. So there are a couple of topics that we're going to cover. Some of those are you're probably already familiar to, guys. That is the bridge fundamentals. Why do we need a bridge, and how we can implement the bridge, the whole system in multiple ways. And then we're going to go deep down into the code and see how it is actually done there. Later, you will see we will do a live demo, and this is going to give you, example how it looks like from a user perspective. I'm going to tell you how it looks like from the code perspective or the developer perspective. If you're going to have any questions regarding the slides that I'm going to show, you can see that in the bottom right corner, there is a slide number. So you have any question regarding a particular slide, make sure that you, with your comment, write the slide number. It's going to be easier for us and, for easier for you to refer to the right slide. Now, let's start with, the bridge fundamentals. This is going to be a high level, approach to see what exactly is a bridge. So in a layman's terms, all blockchains from an abstract point of view can be viewed as completely separate islands. Each island has its own rules, culture, and limitations. If we want to transfer goods from one island to another one, we cannot do it without first building a bridge with them. If we want to go into more technical terms, it will sound like this. The goal of a bridge is to enable cross-chain transfer of assets and information. This greatly increases the value of the blockchains and the value of the assets themselves. Okay, now let's talk about possible implementations of a bridge. I will present you 3 possible implementations, going from the most simple ones to more complex ones. But the most simple one is a simple single node bridge implementation. The bridge consists of one single VM which hosts the bridge binary. Once run, the binary listens for events that can happen on both sides of the chain and initiates a transfer transaction or extrinsic or the other chain if the right event has been received. Now, there are a couple of advantages to this approach. It's super easy to implement and maintain. It's just one simple binary running on one VM. No, it's super easy to do, and it doesn't cost that much. And it enables minimal bridge fee. So no computation is done on the chain itself. Everything is done on the node, on the binary. Now, the problem with this approach is that it's prone to be out of service. It's unreliable. So if for some reason this server goes down, well, the bridge doesn't work anymore because the bridge isn't running. It's the same, and the same point can be said for easily hackable. If the hacker gets access to one single VM or one single binary, it's done. The bridge is compromised and you will lose your money. And the last disadvantage is that you cannot really trust it. All the computation is done on the binary. You don't know if it is going to react to the events. You don't know anything. So yeah, so let's go to the next implementation, and that's simple multi-node bridge implementation. Instead of having just one single node running, we use multiple nodes that somehow communicate with each other to reach consensuses. This node reduces or removes some of the disadvantages like unreliable and unsecure. So if you're running like 15 or 20 nodes, if one of those nodes goes offline, it's not really a big deal. You still have 19 or 18 left. It's the same for the hacking part. If a hacker managed to get access to 2 or 3 VMs or 2 or 3 nodes, well, it's not really a big deal. You still have 70 or 16 left. But the ones we still have one problem, and that's we can't really trust it. The binaries, they do whatever they want to do. Someone can change the binary. You don't know really what's happening behind. The advantage is that it's still cheap to do transactions there, since nothing is recorded anywhere. Everything is in the binaries. The last approach I'm going to show you guys is the complex multi-node bridge implementation. So the communication between the nodes is done on the destination or source chain. With this way, it's fully transparent what exactly is happening. So if the whole voting process or anything regarding the bridge computation is done on the chains, then you can prove what's happening. You can see it. You can debug it. You can do a lot of things with that, and it's way easier and cleaner for the user to see what's happening. Now, since the computation is done on chains and you need to do transactions for that, it's not anymore that cheap. It's now way more expensive. But of course, this is always a challenge in any field that needs some kind of security. You can choose either between a really fast solution but unsecure, or you can choose a super secure solution, which is going to, of course, have its own drawbacks. It's not going to be super fast, and of course, the price or the fees can be huge. But since guys, I think you're aware that a lot of bridges were hacked in the past few years, I think, and that's why we in Ternoa we make sure that our bridge is super secure in any possible case. Okay, let's now deep dive into the bridge architecture itself. So the Ternoa bridge consists of 3 components: the Ethereum smart contract on one side, the substrate palette on the other side, and the relayers, which is a between component. The components communicate with each other by either generating events or by executing transactions or extrinsics. The Ethereum smart contract does not directly communicate with the substrate palette, and vice versa, and instead they use relayers to pass messages between themselves. This is in a nutshell how it looks like. On the one side or the left side, you have this Ethereum smart contract. It's something that you can see, and something you will be use. And if you do a transaction there, like a deposit one, the relayers, they will see this specific log, and then it will initiate a vote for proposal extrinsic on the substrate side. The same goes for the other side. On the substrate side, you will call this deposit function or extrinsic. It will create a deposit made event. The relayers, they will pull blocks. They will parse hold events. They will figure out that this is the right one, and they will initiate a vote for proposal on the smart contract side. So for any activity, let's say on the substrate side, Ethereum side, all the relayers, they of course need to get the right message, and then they need to vote on the destination chain. Of course, we can put a threshold. We can say that 4 out of 10 relays, they need to acknowledge an event or a log, or 5 of 10. It depends, what kind, how secure a system you want to have. Now let's go a bit deeper and look from the code perspective. Now let's take the scenario going from Ethereum to Substrate. From a code perspective, you will call this deposit function on the smart contract that we will deploy. you need to pass the destination ID, that's the destination chain. In this case, if you're going from Ethereum to Substrate, the destination chain is chain with ID 0. You need to write the recipient, which is addressed in SS58 format, and the amount of caps that you're sending, but in units. So if you want to send 1 cap, you need to write 1 with 80 zeros. After the section is called and completed, the relayers will fetch the latest block and look for the specific deposit log object. Now, relayers, especially Ethereum relayers, they listen constantly and pull all the latest blocks from the Ethereum side, and they look for a specific log object that matches the deposit pattern. Once found, it will parse the log, it will construct a message out of it, and it will send it to the router object, which routes the message to the right writer. Now, if you want to see this in a pseudo code language, this is how it looks like. It's basically a loop. We always get the latest block. We look for the deposit log in that block, and for all the logs that are of type deposit, we parse the log, we construct a message, and then we send the message. Now, in the next part, this message that we have sent, this used by the router, and it is sent to the right writer. In this case, since we're sending it to Ethereum to Substrate, the Substrate writer is going to receive this message. Once it receives this message, it will do 2 checks. It will check if the relayer is actually allowed to vote or do anything on the Substrate chain. And after that, it will check if this proposal has been already created, is it expired, or if the relayer has already voted. Now, if the proposal has not expired and the relayer has not yet voted, the relayer will call the vote for proposal extrinsic that either will create a new proposal or vote for existing one. And, the same logic you can see in this pseudocode language. We first check if the relayer is actually allowed to vote. Then, in a loop, we check if the proposal has expired or if the relayer has voted for that proposal. We execute the vote for proposal extrinsic, and we check if the execution was successful or not. If it was successful, then we are done. Now, in the next phase, now we are in the subset palette itself in the vote for proposal extrinsic. We again do the same checks just to be sure that everything is correct. We checked if the person who called this extrinsic is an actual relayer, and then we check if the proposal has already been created. If it has been, we check if it is expired or if the relayer has already voted. If everything is okay, if everything is clear, we vote on existing proposal. If that proposal has never existed in the first place, we create a new proposal. After this is done, we do the last step and we try to complete the proposal, which means we see if the proposal has enough votes, if the threshold has been met, and if this is correct, then we can execute the proposal. And finally, you will be seeing your caps, which you send from the Ethereum side to the Substrate side. You will see if you have sent 100 caps, you will see 100 caps on the Substrate side. As you can see, this is a process. It's not really just one single step. It takes time. Now, let's look at example, the opposite example. We're going from Substrate to Ethereum. It's super similar. The names of the extrinsics or functions are kind of the same. So now, Substrate side, from the code's perspective, you will call the deposit extrinsic. You will pass the same parameters. So destination D in this case is 1 for Ethereum. The recipient needs to be in the Ethereum address format, and of course the caps or the amount, it needs to be in units. So like I said before, if you're sending 1 caps, you'll write 1 with 18 zeros. Once again, this is from the code perspective. From your user perspective, you will not be handling that huge amounts of caps. You're going to just write 1 caps. It's just going to be 1 caps, okay? After the extrinsic is called and completed, the relayers will fetch the latest block and look for the specific deposit made event. Now, just like we had in the Ethereum listener, we have the same logic in the Substrate listener. We get the latest block, we get all the events from the latest block, and we're looking for a specific deposit made event in those array of events. If we find the right one, with the right name, we parse the event, we construct a message, and send the message to the router object, just like we did before. Of course, this router will see that the destination chain is the Ethereum network. It will send the message to the Ethereum writer. The Ethereum writer does the same check as the subset writer. It checks if the relay is allowed to vote, and of course, it checks if the proposal is valid. If everything is okay, if everything is fine, the writer will execute the vote proposal on the smart contract function, the vote proposal function on the smart contract, and it will check if everything went okay or not. If everything went okay, we are done and we will continue. Now we are inside the smart contract itself on the Ethereum side. Again, we will see the same checks that we see on the subset palette itself. So we check if the caller is actually a relayer or someone malicious. We check if the proposal has been created. If not, we create a new one. If it already exists, we need to do some checks, of course. And in the end, if everything is okay, we try to complete the proposal. And if the threshold has been met, then the proposal is going to be executed and you will receive your funds on the Ethereum side. Now, since on the Ethereum side, you need to wait at least 10 or 15 blocks to be sure that everything is correct. It's a bit slower than on the subset side, but that's the nature of the chain itself, and this is not something that we can change. So if you're sending from Ethereum to subset, it is going to be, of course, faster than if you're sending from subset to Ethereum. Now, is this bridge that simple? Not really. The architecture is a bit more complex, and it contains many more features and checks. But for the sake of this presentation, we have omitted this. One of the features is the resend or replace mechanism in cases the transaction on Ethereum is stalled. Of course, we need to get the right gas price and gas limit. This as additional logic, and we need to cover, and we are covering all the possible edge cases, which there are many of them, both on the Ethereum side and on the subset side. Of course, besides having a robust bridge architecture, we need to think about the other side, which is basically that we need to make sure that our VMs that are running the bridge, called the binaries, they need to be secured too. They need to be monitored for any suspicious activities so that in any case, no one can break in who is not supposed to break in. And that in cases, God forbid, if someone breaks it, we can see it immediately and we can react immediately. Okay, and that's all, folks, for me. Please write your questions in the comment section. If there's a question from a slide, of course, write the slide number. And after we are done with the demo, which is going to happen quite soon, we'll be reading your questions and we'll be answering them. That's all for me.
Thanks, Marco. That was great. Before I hand you over to see the demo, I'll just share a few background points. To paraphrase what Marco said, we have deployed a bridge that on one end will connect to the Ethereum test network, and on the other hand, it connects to the Ternoa AlphaNet. The bridge uses an architecture of trusted relayers with threshold voting schemes, which means that unless the threshold is reached, the transactions will not be processed. So that's just to make sure that any malicious takeover of nodes will not have an impact on the transfer of tokens or the funds. And all these are running in a very secure infrastructure. We take security very seriously, doing everything we can to make sure that in terms of whether it's code audits, the penetration testing, making sure we have a secure infrastructure. So a lot of steps are being taken to ensure that the funds will be secure as you move it between chains. Some few other pointers before you see the demo is first and foremost, when you on the Ethereum side, you need to have caps and you need to have ETH. So both tokens. That's because ETH is the base token on the Ethereum chain, and that is what you use to pay the fees. So when you're sending funds from or tokens from Ethereum to the Ternoa chain, you need to have base ETH to pay the transaction fees, and of course the caps that you want to transfer. On the Ternoa side, all you need is caps, and for testing purposes, you can go to a faucet, and you can get those test caps and use that for testing purposes. Another aspect I want to highlight is that on the Ethereum side, you will pay the fee in ETH, and on the Ternoa side in terms of caps, and but the speed of the transfers can vary. That's because Ethereum, as you know, uses a probabilistic finality consensus algorithm, whereas on the substrate side, it uses both we use both Babe and Grandpa, which is both probabilistic and deterministic finality. So because of that, on the ETH side, you will not know exactly when the transaction is confirmed, and the chain will not be reorganized. So we have to wait for a minimum number of confirmations, and that's why when you're transferring tokens from Ternoa to the Ethereum side, you'll find it may take a little longer because we have to wait for the confirmations, but the other way around should be fairly quick. So with this background, I hand you off to Aman, who will actually show you what you're waiting for, which is the actual working of the bridge. Over to you, Aman.
Thank you so much, Prabhu, and thank you so much, Marco, for structured presentation, and also Prabhu for sharing, the critical piece of information regarding the security. I'm pretty sure there are a lot of questions, guys, regarding this, and please use the comment section on your screen and send us all your questions. We'll make it a point to answer them after the demo. Alrighty, so let's move on to the moment you guys have been waiting for. Okay, it's already there. Ta-da! I wanted to do this, but yeah, it's already there. No worries, I still did it. All right, so one thing I would like to mention, here is that we at Ternoa, we love user centricity. We're always trying to make user experience around our products as smooth as possible and as secure as it can get. And we are always trying to learn, and we are iterating. That's our key principle we operate on. And without any further ado, I would say let's start with the demo. So first things first, let's try to familiarize ourselves with the entire web screen. There's some warnings because this bridge at the moment is on AlphaNet. And I mean, it's not risky at all to use it. You can use, you can definitely use the AlphaNet test caps to send it around and fiddle with the bridge. I will show you where you can also claim those AlphaNet test caps, and also you can see, of course, you need some wallets. So the wallet, from the Polkadot, you need a MetaMask wallet, and also you need the Binance wallet for the Binance transfers. So I've got everything sorted here. So let's start. And first, I'm gonna show you a transfer from the substrate side to the Ethereum side. So here you can see I've already selected the Ternoa chain. And now I would go ahead and try to connect my Polkadot wallet. I have two accounts. The one with Tech AMA I created specially for this purpose. It has more money as well, but it's just testnet caps. Doesn't really make me that happy. Okay, so this is connected here. Basically, a window should pop up, and you're gonna have a screen where you're gonna be asked for a password. You have to enter the password, and then basically it gets connected here. And now, as the to chain or the destination chain is Ethereum chain, I would like to also connect my Ethereum wallet here, and I would click on MetaMask. Yeah, unfortunately, there's no pop-up because I've been using this quite a lot, and it's already connected. But for the information purpose, there's going to be some sort of this pop-up which would tell you to sign the sort of confirm that you are connecting your MetaMask wallet with the Ternoa network on this bridge. So also, things to ponder here is, sorry, you have a view of your balances, both on Ternoa chain and on the Ethereum chain. And of course, your address shows up here, which is a bit truncated, but it's still here. So I would say let's try to send somewhere around 40,000 caps. And just warning, there should always be some caps left out. You should never, try to send maximum caps, because if you like click on maximum, it's gonna take the closest integer value to the wallet balance, but then it's gonna prompt, if I click on continue, it's gonna tell me that I don't have sufficient amount for the transaction fee. So always be careful, always have 10 to 20 or 30 caps set aside for the transaction. So that's why I'll just take a random number, 40,000. I'll click on continue. So here you can see on this model window, I'm sending my caps from Substrate network to Ethereum network with my wallet addresses. The network fee is charged in caps. It's really minute fee. Also, there's a bridge fee, which is 10 caps. And the total fee is 10.0145, which is super minute, super small. And it shows you the amount you're going to get. So I'm going to click continue. And I have this pop-up here from Polkadot wallet. And I need to sign the transaction. So I need to enter my password. I'm going to enter my password, and I'm going to click on sign the transaction. So basically now the process starts. And we'll have to wait a couple of minutes, like 2 to 4 minutes or 5 minutes, as Marco already told us that it takes a bit longer to send caps from Substrate to Ethereum side. So yeah, let's wait. In the meantime, once the transactions get approved, we also provide you with the link to the Explorer. So here we can see the Ternoa Explorer. We're gonna click on it. You're gonna see, you can see all the information related to the transaction. You can see the block ID, the block number, what time the transaction was initiated, and some extrinsic information, the fees, or overall amount that's being transferred, which is under parameters. You can see here. So it's 40.000 up to 18 decimals. And basically, yeah, the address where this is being sent to. Okay, so yeah, basically a lot of information here. Let's go back and see. Yeah, so basically the relayers are now working their magic, and basically we still have to wait a couple of minutes until they vote and they basically execute the transaction on the Ethereum side. Please bear with me, guys.
Okay, while we are waiting, I just wanted to add another point here. You would have noticed that for making transfers, we're asking you to connect both your Ethereum wallet and the Polkadot wallet. It is actually a security measure for two reasons. Number one, by connecting to both your wallets, you will not have to manually enter the destination address and make mistakes. And secondly, you make sure that you're not sending it accidentally to somebody else's wallet. So you'll be sending funds from your wallet, let's say from Ethereum, your MetaMask, to your Ternoa Polkadot.js wallet. So I just wanted to highlight that, it's a security feature we've built in to avoid mistakes. So yeah.
Thank you, Prabhu. Well, that's the difference between product manager and a tech guy. He's always worried about the security. Thanks, Prabhu. Yeah, we are still waiting. As I said, it's gonna take 2 to 4 minutes. So guys, yeah, please bear with me. I wish I had some music for you, but unfortunately not. Or maybe in the meantime, we can take questions. Quick question regarding, maybe well, audit security. Will the bridge be audited? So, Prabhu, you would like to answer this question?
Yes. So the question is, will the bridge be audited? Yes, of course. So let me tell you how we went about constructing the bridge. First and foremost, we took a code base that has been battle tested already. Many projects use it live on the mainnet, including many projects in the Polkadot ecosystem, and that has been stringently audited already. And for the portions of the code that we are modifying, we are commissioning an external audit, and that will be done. We're also commissioning we did an internal penetration testing audit to make sure that the infrastructure is secure. We're going to commission an external audit as well. And these will cover things like, DDoS attacks, and, trying to access, ports, checking whether all the ports are closed, and also, trying to access from unwhitelisted IP addresses. It's a whole range of security measures that we put in place. People are going to try to break it from outside. So that's what our external agency will do. In addition, we're also going to set some transaction limits for the bridge. For transactions for high value, for example, above 1 million caps or so, you also have the option of using an OTC kind of a setup. So there are many different steps we are thinking about, and we've already implemented some of them. But rest assured that this is topmost on our minds. We've seen a lot of, in the other ecosystems, other chain ecosystems, we've seen a lot of instances of the bridge being a weak component, weak link in the chain, which is understandable because we're talking of transmitting assets between two different chains which don't really understand or talk to each other. So you have to rely on some intermediaries like the relayers. And our focus is to make sure that we make this whole end-to-end transaction flow as secure as it can be.
Cool. Thank you so much, Prabhu. I hope that answers the question. All right. So I see 3 green ticks here. I can show you that we have the transactions recorded also on the Ethereum side. Basically, what relayers are doing. So it was confirmed. There were 9 block confirmations 2 minutes ago, and same for the other. Yeah, so 6 block confirmation 1 minute ago, basically. So it's a huge success. So yeah, 3 green ticks. Let's see if my wallet is greener or it's just green. Ooh, yeah. So now I have 1.04 million caps in my account. So it was a success. It takes a bit of time, as discussed, but yeah, you don't need to be worried about your funds being lost. Just be sure that you enter the correct wallet addresses, and basically the wallet address of whose security keys you own or you know. And I think that should be fine. Nice. Now we can try it the other way. So what I'm gonna do is I'm gonna disconnect both the wallets. I'm just gonna try to swap the networks. So now you can see the destination. So the source network is Ethereum network, and the destination network is the Ternoa chain, or the Ternoa network. I would try to connect the MetaMask wallet. So it's already connected, and now I would like to connect the Polkadot wallet. That's connected as well. And now I would like to send back the 40,000 caps that I transferred initially. And let's click continue. And now basically I have to approve this transaction. So it's going to go to the MetaMask. And MetaMask is going to ask me, does it has the approval of me or not? And basically I have to approve the contract first. So I need to give permission to access my wallet details, and I'll click confirm. It's going to take a couple of seconds. Cool. So now, once we have approved MetaMask of using our wallet and our funds, we can see now we have the network fee that is going to be charged on the Ethereum side in ETH, definitely. So now, we can check, okay, the address that we are sending to is correct. I'll click on continue. And now again, I have to confirm or sign this transaction, just as I did with the Polkadot wallet when I was transferring from Ternoa to Ethereum. And I'm going to click confirm. This should be a bit faster. And of course, you're going to have the links to Etherscan Explorer, Ethereum Explorer, and also the Ternoa Explorer to check. So it's still indexing at the moment. And now the relays are doing their magic. Okay, so it's a success on the Ethereum side, and we're still waiting for the relays to confirm the transaction.
Aman, can I add a point here?
Yeah, please.
Okay. So you'll notice that when you're on the Ethereum side, when you're initiating a transaction, you will have to approve two transactions. When you're doing it for the first time, there's an approval transaction that is needed because you will have to approve the smart contract to take the funds from your wallet. But once you do it the first time, after that, you can just have one transaction to initiate the funds flow. On the Ternoa side, you don't have such restrictions. It's just one transaction you have to do. There's no approval and send. I just wanted to highlight that because on Ethereum, if any of you must have interacted with dApps, and all the dApps follow the same model because you have to do an approval first and then and that's why you need two transactions there.
Sorry, I was muted. Thank you, Prabhu. So here we can see all three green ticks, and it means that the cap should be in my Ternoa wallet, and we can see the amount changed. It was somewhere around 49,000, and now it's 89,944. Of course, excluding the fee. And I think I should also show you guys where you can find the where you can claim the caps for the AlphaNet test caps. So basically, you go on to Ternoa.com, you need to scroll down, you need to click on AlphaNet Faucet, and basically here you can see you need to enter your wallet address, and you need to solve the ridiculous, most difficult puzzle. So let's try it out quickly. I'm gonna copy the wallet address. I'm gonna paste it. Yes, I'm not a robo. And then I'm gonna click on claim. Oops, I need to wait for 15 hours. So I've already claimed test caps using this account. I can try it from a different account. Was it this one? Let me try this one. Okay, so basically, maybe well, I already have a lot of caps, and we have restricted this functionality. Well, firstly, one IP can only claim once every 24 hours. Otherwise, we were seeing a lot of bots who were trying to claim these test caps, and it was causing issues because these test caps are just for the testing purpose, and some of the members in the community, they thought that they are actual caps. But anyways, this is where you can claim the caps to test out the bridge. And here's the link to the bridge. It's also pinned in the comment section. And basically, that was the bridge, Ternoa bridge, and yeah. So that was the demo. I hope you guys liked it. We are very interested to know your thoughts. So please send us your questions using the chat option, the comment option, and we can then move on to the final section of the AMA, which is Q&A, and jump right on to answering your questions. So I do have some questions, well, mostly related to audit. I think that has been already answered. Then there's another question, if there's going to be a step-by-step guide or like a to-do video. Definitely, there's already a document which is live, and we can post the link in the chat, and we are also planning a video, official video, which would be actually go like a demo, like a animated demo, and that would be out soon as well. Then there's another question. So there's a question regarding the connection using the wallet. I mean, it depends if you are sending, well, irrespective of the site you're sending or the chain you're sending your caps to, you can definitely have two accounts within a MetaMask wallet or in a Polkadot wallet. So you can use whichever wallet address you want. But it should be basically the correct one. So just be careful. I think those were the questions. Yeah, there were a lot of questions regarding the audit because, of course, it's a really complicated thing, and everyone is worried about their assets. And I think Prabhu has already mentioned it. Oh, there's another question. When can we expect the bridge to be ready and be available on mainnet? So Prabhu, do you want to jump in here regarding the part when can it be completed, when it's going to be fully ready?
Yeah. So normally for the way we plan the releases is once we launch the AlphaNet, it's very important for us to make sure that it's tested thoroughly. Even though we have done internal testing, we'd like the community to test and give us feedback. And really based on that, we'll be able to decide what is the right time to launch the mainnet. So I'm unable to give a specific date, but it all depends on how quickly and actively all of you participate in doing the testing and give us feedback.
Definitely. So guys, please, I mean, the link is already there. You know where to claim the test caps for the AlphaNet. Please go ahead, try it out, and give us as much as feedback you can, so that we can work on it and push this out as soon as possible. Testnet is no longer incentivized. I mean, it was only until the 31st of March. There was a question in the comments. Do we have more questions? All right, so a couple of guys already using it. They say pretty smooth. Thank you so much. You're welcome, guys. Thank you for being here. Ben, would you like to add a couple of words?
Hey, I'm mute. Yeah, I see the community is testing, so it's great. Hi everyone. I don't know if we miss me the earlier on this live. So there are not a lot of questions. So I think the everything will be said on the live. And thank you all for participating. It's a big step for Ternoa, and special thanks to the tech team. In a nutshell, you can try our new bridge right now on the URL on the link we shared, and don't forget to get some test caps on the AlphaNet. There is also documentation on our official documentation, and hope you enjoyed this new format. We will make other if you like this, and give us feedback on our Discord, and yeah, the community team will be happy to support you. So bye and thanks everyone.